In this video, we're going to talk about power in circuits and how power is dissipated. A great way to look at power in a circuit is to think about light bulbs. Now we're going to think about incandescent light bulbs, which are kind of old school by now because most of the light bulbs we use are compact fluorescents. But an incandescent light bulb has a very small wire in it called a filament, and that filament has a really high resistance. So the electrons that are passing through that filament collide with the atoms that make up the filament, and in that collision they transfer some of their energy to the filament. When enough energy is transferred to the filament, it causes the filament to heat up. It gets so hot that it actually glows. Now, this is one of the reasons that incandescent light bulbs are so inefficient, because about 90% of that energy goes to heat, and only 10% of it is visible light. So that's why our community and our country is trying to move towards compact fluorescent light bulbs, which are much more efficient. But incandescent light bulbs give us a great way to look at power dissipation in a circuit. So let's think about the factors that affect the brightness of a bulb, or the power dissipated by a bulb. What is power? And we studied power when we were studying energy, and we remember that power is equal to energy divided by time. So like a change in energy over a change in time. Now, energy as it pertains to electrons is Q times V over T. So energy is QV, where V is your potential difference or your voltage. And we can put a delta V there for some of us. We like that better. Now, if I look at this right here, Q over T is current. So we have current times delta V. So we get this equation, P equals I times delta V. And I also know that delta V equals IR. So I can plug that into here, and then I get P is equal to I squared R. And then I can also solve for I. I is equal to delta V over R. And I can plug that into there, and then I get P is equal to delta V squared over R. So I have three different equations that I can use to determine the power dissipated by a bulb or a circuit. Now let's talk about why each of these things actually causes brightness. So if current increases, then what that means is that more electrons flow through filament. I think filament has one L. I'm a physics teacher, not a speller. Okay, so then more electrons flow through the filament, and therefore there's more energy transferred because each electron has a certain amount of energy, and so if there's more of them, more energy is transferred, and so therefore the bulb is brighter, which is so exciting. So that's how current affects brightness. Now let's talk about resistance. If resistance increases, then that means it is harder for the electrons to pass through. And it's harder because the electrons make more collisions. And we know that with every collision, they're transferring energy. So they transfer more energy. Then therefore, the bulb is brighter. So if I have the same amount of current going through a bulb, but it has more resistance than an original bulb, the bulb with more resistance will be brighter. Then we can also think about voltage. Now remember that voltage, if this increases, then remember voltage is like energy per charge. So each electron will have more energy. And therefore, more energy is transferred in the collisions. And therefore, the bulb will be brighter. All right, so let's apply this. If I have two bulbs that are identical in a circuit, these bulbs have the same brightness because they have the same resistance, the same current, and the same voltage. Now let's say that I add a third bulb in there. What will happen to the brightness of the bulbs if I add a third bulb in there? Now I know that our resistance stays the same because the resistance of each bulb is the same. So for each bulb, the resistance stays the same. So what I need to think about is how the voltage of each bulb, if it changes, and the current, if it changes. So I know that the equivalent resistance of the first circuit is equal to 2, let's say that each bulb is 1 ohm. It's not really, but let's just say, is equal to 2 ohms. But the equivalent resistance of circuit 2 is equal to 3 ohms because there are 3 resistors. Now, I know that my delta V is equal to IR. So I is equal to delta V over R. So that means that the current in the circuit decreases. So there's going to be less current going through each of these bulbs than there was going through each of these bulbs because this circuit has more resistance, and therefore, if this battery is the same, then the current is going to decrease. So therefore, we can expect these bulbs to be dimmer. We can also consider voltage. We know that the voltage drop across each of the components within a circuit has to equal the voltage drop of the battery. So since these are the same resistance, they're going to have the same voltage drop, 2.5 volts of 2.5 volts each. And same for this one. But this time, there are 3 different bulbs. And so we get 5 divided by 3, which is like 1.7. And so our voltage drop is lower, and therefore the bulbs will be dimmer. Now let's look at these bulbs which are identical. These are parallel. If they're identical, they will have the same resistance, the same current, and the same voltage. So they will have the same brightness. Now let's add another bulb in. What happens to the brightness when we add a third bulb into the circuit? And this is this gets a little complex because we have to consider several different things. First of all, REQ of circuit 1 is equal to 1 over 1, let's just say they're 1 ohm resistors, plus 1 over 1 inverse. So that's going to be 1/2. Because you get 2 inverse, which is 1/2. REQ of circuit 2 is 1 over 1 ohm plus 1 over 1 ohm plus 1 over 1 ohm. So that gives us 3, which is 1/3 ohms. So it has less resistance, which means that it's going to have more current. However, in this circuit, the current splits 3 ways, because here's your total current, and it can go through this bulb, or it can go through this bulb, or it can go through this bulb. The current in this circuit only splits 2 ways, 1, 2. So this circuit with 3 bulbs has more current, but it splits 3 ways. And so now we have to figure out how much current there is going through each bulb. So we have a battery that is 5 volts. So let's figure out what our total current is. So we know that I of the first circuit is going to be equal to 5 volts divided by 1/2 ohms. So that gives us 10 amps. And then the current in the second circuit is going to be 5 volts over 1/3 ohms, which gives us 15 amps. Now, this current in the first one splits two ways because there are two resistors. So each resistor, or each bulb, gets 5 amps of current. This one splits 3 ways, and guess what? They get the same amount of current. So, these bulbs have the same current going through them as bulbs, bulbs in circuit 1. So they will have the same brightness. And there's a lot of ways you can apply this in like everyday circuits. If you have a power strip that is wired in series or in parallel, so if you plug an extra light into your power strip, it's not like your fan starts spinning more slowly. It will keep the same. Also, Christmas lights, if you take a bulb out, the other ones don't get dimmer or brighter. So we can explain that with current, and then we can also explain it with voltage. When we are in parallel, the voltage of each bulb is the same as the voltage of the battery because they're in parallel with the battery. So these each have 5 volts. And then if we look at the circuit with 2, these each have 5 volts too. So they all have, these bulbs have the same voltage drop as these bulbs, and so they're going to have the same brightness. However, the difference between these two is that the total power dissipated by this circuit is less than the total power dissipated by this circuit. Each bulb dissipates the same amount of power, but there are 3 bulbs in the circuit and only 2 bulbs in the circuit. So this circuit is going to drain the battery more quickly.